Hey there, universe nerds. Time travel has fascinated us for centuries. From ancient myths to Hollywood blockbusters, we've always dreamed of stepping into a machine and zipping into the past or leaping into the future. But here's the shocking part. Time travel isn't just fantasy. Physics says it might actually be possible, though not in the way you've seen in the movies. Today, we're exploring the real science of time travel, what's allowed, what isn't, and what it could mean for the future of humanity. First, let's clear up a fact. You are already a time traveler. Every second, you're moving 1 second into the future. But real time travel, the kind that lets you jump ahead by decades or centuries, requires something more. According to Einstein's theory of relativity, time isn't absolute. It's flexible, stretchy, and depends on speed and gravity. That means if you move fast enough or get close enough to a massive object, time will pass differently for you than it does for others. This effect is called time dilation, and it's not just theory. Astronauts on the International Space Station actually age slightly slower than people on Earth because they're moving so fast and orbiting in weaker gravity. It's only milliseconds, but it proves time can bend. Take it further, and if you traveled near the speed of light, you could leap thousands of years into the future, while only a few years passed for you. That's one real form of time travel, into the future. But what about going into the past? That's where things get tricky. Einstein's equations do allow solutions where time loops back on itself. These are called closed time-like curves. In theory, wormholes or cosmic strings could act as shortcuts, not only through space, but also through time. But here's the catch. Going back raises paradoxes. The most famous is the grandfather paradox. If you went back and prevented your grandparents from meeting, how could you exist to travel back in the first place? Some physicists argue that paradoxes might be impossible because the universe is self-consistent. This is known as the Novikov self-consistency principle. If time travel to the past is possible, you could never change events in a way that creates contradictions. In other words, history is fixed, and your actions would always fit into it. Others think multiple universes could solve the problem. Travel back, and you branch into a new timeline, while the original one continues untouched. That's where time travel connects with the multiverse. Of course, building a working time machine is another story. The energy required to bend space-time into a loop or to stabilize a wormhole is far beyond anything humanity can produce. Exotic matter, negative energy, or quantum tricks might be necessary, and we don't even know if those things exist in usable amounts. Right now, time machines belong to chalkboards and computer models, not laboratories. But even without machines, time travel shapes real science. Studying relativity and quantum mechanics has led to technologies we use today, from GPS satellites to particle accelerators. And by pushing these theories, we learn more about black holes, wormholes, and the fundamental structure of space-time. Even if no one ever rides a time machine, the pursuit of time travel forces us to confront the deepest mysteries of the universe. And here's a wild thought. Maybe time travel already exists, just not for us. Some scientists speculate that if advanced civilizations exist, they might have already cracked the code of bending time. Or maybe signals from the future are already buried in physics, waiting for us to decode them. It sounds crazy, but remember, 100 years ago, even black holes sounded impossible. So, can we travel through time? The honest answer is yes. Into the future, definitely. Into the past? Maybe, but with huge challenges. For now, time travel remains the perfect mix of science and imagination. Real enough to be worth studying, mysterious enough to inspire wonder. The next time you glance at a clock, remember, time isn't just something we measure. It's something we might one day learn to master.